Hi, I'm Greg, lead developer advocate at Hedera Hashgraph, and this is a description of our cryptoeconomics.
What are cryptoeconomics, and specifically, what are Hedera's motivations for getting it right? So the first one is to avoid tragedy of the commons, and tragedy of the commons is historically the result, or not the result, but what was happening when animals were grazing in a common area of land. And they were doing so for free, which meant that it was turning into the resources being overused to the point where there was arguably no grass left for the animals to graze, which was in nobody's benefit. So we're trying to avoid tragedy of the commons through our cryptoeconomics. We need to balance resource utilization. Resources are being used when transactions or queries are sent to the network, and these resources have a cost. And we're also trying to incentivize people to do the right thing by influencing their behavior for the good of the network, and equally disincentivize. Seems anything over 10 letters today, I'm not getting. Disincentivize people to act maliciously. And that's all part of the cryptoeconomics puzzle. So how do we address it? So first of all, the network is paying nodes to be nodes on the network. That's an incentive for them to be nodes. And users of the network are paid through proxy staking, so they can help the network work well. You proxy stake, you get something back. In exchange, to use the network, you pay transaction fees. As I said, this could be the developer of the app paying transaction fees, or it could be the end user of the app paying transaction fees. For example, with the daily timestamp, Hedera built the app for the browser, the micropayment extension, but you, the client or the end user, were paying for the transaction fees. The daily timestamp wasn't doing this, or the extension wasn't. You were, and then data micropayments or tiny micropayments to get information from the network, from the nodes or mirror nodes, can be set up such that if you're a mirror node, you can do this for free. But you can then sell information to people and services around that particular information, which is an incentive for people to run mirror nodes and additional services. So this is a network. It's a bunch of computers, and they all come to consensus, as we've discussed earlier. If you store a file, they all store that file. If you run a smart contract, they all run the smart contract. And they come to consensus on what the results are. They come to consensus on what you're storing. You're feeding in transactions, and they agree on the exact time of each of those transactions and the order they came in. That's their job. So when you want to do a transaction, to move some HBAR, for example, from one account to another, or run a smart contract or a file, you create a transaction as a client, you sign it, and you send it to a node. Any of the nodes on the network, it doesn't matter. And the nodes will then gossip to the whole network. We've seen this earlier. So this transaction spreads out, the whole network sees the transaction, and all the nodes can collaborate to come to consensus in an ABFT way. So that's what happens with a transaction that goes to the network. A query is a little bit different. A query just goes to a particular node. If you ask a node, what is my balance? The node will tell you. The node has a copy of state. It has all the account balances in memory or in state. So it's able to respond to your query without asking the entire network. If you didn't trust it, you could ask another node, and the node will give you theoretically exactly the same information. The query doesn't bother everybody else. It's only asking the node. It doesn't have to be gossiped. There is no consensus is just a conversation between you and the node. Okay? So, queries and transactions, by definition, have different resource requirements in terms of what they're using on the network. If we're gossiping it, we have to check digital signatures, we have to do consensus, the network between the nodes is being solicited. So transactions take a bit more than queries. So we should show this in the cryptoeconomics. And this slide sort of tries to show the sort of resource utilization versus operation. It really is for illustration purposes. I don't know that a query is a third of a file storage. That depends on the size of the file or a smart contract. But nominally, queries will require less resource usage than transactions. So when you do a transaction, you pay a transaction fee and you send it to a node randomly. They send it to everybody else, and you would imagine maybe the node takes some of that transaction fee and the network takes the rest. And that's roughly what happens. So why have a transaction fee and why not make it free? There are other options available. The fees could be hidden through a tax on accounts, which would lose money every day. We could do inflation, which is even more invisible as a tax, but we don't like that very much. So we feel that it's cleaner if everything is clear. Transaction fees are clear if you pay for what you use. You're not paying for things you're not using, and we're aligning the resource usage with the pricing and the cost, trying to ensure we're incentivizing people correctly. If we, for example, tax every account, then why should somebody pay, why should the tax be, if it were flat, why should it be the same for everybody, regardless of their network usage? Surely those who send 100,000 or 10 times more transactions than others should pay more for the usage of the network than those that send none. So a tax on accounts is not a fair way of paying the network, and it's not creating the right incentives in any case. So we don't want to incentivize anyone to flood us with lots of requests either. So, for example, somebody could ask to store a file for 100 years. Well, if they want to do that, we would charge, well, Hedera would charge them accordingly. If it weren't charged, then anyone could store files, large files, for a very long time, and not incur the cost of doing so. So essentially, everything is clear, everything's on the table. You pay according to how long you want to store things. If you want to store a file longer than initially planned, you can pay a little bit more and it will be stored longer. Likewise for smart contracts and transactions, the economics reflect the exact resource usage. So how is a fee calculated? So the user is paying a transaction fee, but what's happening behind the scenes? And this is the detail that we're teasing out today. So you call the SDK, and at the moment in the SDK, the fees are flat, but ultimately the SDK will allow you to calculate a fee for any given transaction, be it a crypto, a file, or smart contract to a point. But where's that number coming from? So we're trying to make it right, sustainable. So a transaction fee is made of a network fee, a node fee, and a service fee. The network fee exists because a node receiving a transaction and gossiping it is obligating all the other nodes to do some work. If I gossip to Alice, Bob, Dave, and so on, I'm kind of forcing them to listen to my gossip. So I'm using the network, I'm using their bandwidth. At the same time, they'll be doing some computation. They have to store my events. They have to work out my signatures, and so on and so forth. So I'm essentially asking them to use resources of their own. So there is a fee, a network fee, to gossip the transaction around the network, and that depends on the size of the transaction. A node fee, the node receiving your request is kind of doing you a favor. It received a transaction on your behalf, it submitted it to the network, the other nodes just sat there waiting for gossip. So it's done a little bit more work than everybody else. So there needs to be a node fee that goes to the nodes. If we didn't have that, then nodes could decide to be just a node and not talk to any clients, and then the whole network would grind to a halt with API calls not going into the network. So every node is going to get the node fee, which can be very small because the effort is very low. A bit of conversation with you and a bit of conversation with the network. So it's not a lot, but it's a little bit of something, and we want to make sure that a part of the transaction fee accounts for that node accepting your transaction and forwarding it onto the network. The service fee, on the other hand, is for the rest, and it doesn't have to be very much. It will depend on the service. If you want to store several gigabytes of data for a century, then it would be expensive. If it's a few bytes for a few minutes or a few hours, then it could be very cheap. So the service fee will depend on the particular service and the characteristics of that service that you're requesting from Hedera. Likewise, if you ask for a record or a state proof, then those have additional computing requirements in terms of generating them, and therefore there would be a service fee attached to those being generated. But the service fee depends on what you're asking the network to do. It's quite simple, and if you're asking for a lot, then it will be relatively expensive, relatively speaking, and if you're asking for a little, then it will be relatively low. So the fee calculation is pretty straightforward. It's invisible to the end clients, but so it's the network fee, the node fee, and the service fee. But the point here is to stop attacks. We want the network to be trustworthy, and if a node were to be malicious and were to spam the network with lots of fake transactions from a user that doesn't actually exist, it's called a fake client. So I set up my node and I start spamming the network directly with transactions that I generate. How would that work? Or how would we prevent it from happening? Let's assume for a second that there is no client and the node is generating 10,000 transactions and throwing them into the network, asking everybody to gossip them. They check signatures and they eventually maybe come back to, when it comes to consensus, kind of go, no, they're all false, they're all fake. They may not reach or affect state or reach consensus, but the point here is that all those nodes have wasted resources dealing with these tens of thousands of invalid transactions. So we can put some throttling in place, and that facility exists. But we want to incentivize nodes to do the right thing, not necessarily allow them to simply waste resources. So the cryptoeconomics implements the incentive for nodes to do the right thing as follows. A client's transaction fee is essentially paid to the node, which, so the client paid part of their transaction fee as a network fee, which reimbursed everybody for gossiping it. the node doesn't care about that particular network fee because that kind of goes, the node in itself doesn't care about that particular price. When there is a client, the client pays the node pays the network, and the two payments are equal. So the node it's just a zero operation, so to speak. But if the node is malicious, there is no client. It means the node is paying for the network fee and all the effort of gossiping and checking signatures. So the node essentially has to then start paying for those itself. These 10,000 transactions or dishonest transactions, it then has to pay for. And the rest of the network arguably doesn't care because they get paid for dealing with these malicious transactions. They may not result in consensus or state change, but essentially they've not wasted resources because they've been paid for. So the economics work out. The resources being used are paid for. There would be no service fee because there is no service being invoked at this particular point. The events would be thrown away. The nodes participating in consensus have all received their network fee or will receive their network fee, and the node, the malicious node, would essentially be paying all of those calls, malicious calls to the network. So that's a disincentive for them. Unless they wanted to waste their funds doing so, there is no incentive for them to do so. So transaction fees are simple. What the client sees is a node and the network. The SDK will allow you to calculate these particular transaction fees. So why would somebody want to be a node? So we're starting with council members running nodes, but ultimately the whole planet, we want the whole planet to be running nodes. Anyone running nodes, millions of people, the number of nodes will eventually grow to lots and lots and lots. So we know now how to protect ourselves from malicious nodes. But how are we going to attract them? What would make it attractive for someone to be a node? Actually, you get paid for running a node. So that the majority of ledgers do that. How would nodes be incentivized in Hedera Hashgraph? So with proof of stake, whoever's running a node has an account with HBARs in it. It's the cryptocurrency, and they're staking that cryptocurrency to their node or node's account. So once a day, we're going to pay, or Hedera will be paying the node a given payment for being there and participating in consensus. So the bigger the stake, the more you helped with consensus, and therefore the payment proportion will be, the payments will be proportional to that amount of stake. But there will be limits. There will be limits to how much can be staked to a given node to limit sort of nodes essentially taking over consensus. What I haven't said in any of this is the words bond or slash. So the nodes can spend its cryptocurrency, and if you proxy your coin to a given node, you can carry on spending your cryptocurrency at any moment. It just means that you or the node spending that cryptocurrency will be paid less because the stake has lowered. At the same time, you could be earning HBAR, and in this respect, your stake would increase. But the point is that there is no slashing and there is no bonding. Unlike other networks, and we talked about it a little bit this morning, or this evening for some of you, on the different DLTs, we don't penalize nodes acting maliciously by taking their money away. They're kind of volunteering it to Hedera Hashgraph by running those malicious transactions. So there are no fines, there is no, as I said, no slashing, nothing's at risk. You get paid if you're good, and you don't get paid if you're bad. And that's as simple as that. So that explains to a certain extent why you might want to be a node. Now, looking at the mathematics of being ABFT and the mathematics of our proof of stake. So you can't do any better if you have a world of DDoS attacks and malicious firewalls. No system in this particular world where we have DDoS attacks, firewalls and bots and so on can survive more than a third of nodes being malicious. If every computer has an equal vote, you can't have, you're at risk of a third of computers being malicious. So if every HBAR and every token has an equal vote, then you have to make sure that a third of those tokens are not being malicious or not participating. If a third of the tokens are owned by malicious people, they can do bad things. And if a third of the tokens are owned by people not running a node and they're not participating, that's bad. And that could stop us from coming to consensus. So what do? We encourage people to proxy stake, and we've covered this a little bit earlier. So anyone can proxy, anyone who has HBAR can proxy stake to a node. And when they do that, the node's voting is weighed according to the tokens plus your tokens. It's all fairly straightforward. Now, that helps the nodes contribute to consensus. We said earlier that the node receives higher payments if its stake is higher, because it has a higher degree of participation in consensus. So what's going to happen when you stake your token or your coin to a given node? Well, the node will share its payments, or the payment it receives from the Hedera network, with the clients that have proxied to it. So that's the incentive for every account holder to proxy its stake to a node in order to reduce the likelihood that a third of the coins are not being used towards consensus. So if we give clients the right incentives, which is to earn interest, if you want, on what they have in their account in terms of HBAR, then why not do it? And that incentives aligns well with human behavior and game theory. So that's what we'll be trying to do. So that's it. Or people are encouraged to proxy stake their coins. Nothing's bonded, nothing's locked up. Again, as the nodes were able to spend and earn coin while staking, you can carry on earning and spending coin while they're being staked. There is no lock-in, unlike savings accounts where maybe you put your money somewhere and you can't touch it for several months. Your coin remains completely available. You can't lose them, even if the node is malicious. You've not given your coin to that node, only your proxy stake. Obviously, if the node is being malicious, then it may not receive the same proxy payments that it would normally receive, or the node payments. So you may be interested in shifting your stake to a non-malicious node, which would be running transactions and therefore attracting a higher degree of payments. And equally, if a node is inactive for a large proportion of the day, then the node payments would be reduced. So again, the incentive there is for nodes to run as continuously as possible. And I guess, I don't know for sure, but maybe some of those parameters will be adapted over time as the number of nodes grows on the network. But certainly in the early days, a high quantity of node participation, if you want, is expected. So that's how we handle the payments. We talked about queries earlier. So let's have a look at how cryptoeconomics affects queries that don't bother the entire network. There's only a node you're having a conversation with. You're asking it to do a favor and give you some information, what a balance or what's the contents of a file. Does the file even exist? Did I delete the file or any of those things? So this sort of information that a node can give you without going to the network. But there's more. You can talk to a mirror node, or rather, you will be able to talk to a mirror node. Mirror nodes are part of our later plans for this year. So what is a mirror node? It's something anyone would be able to run sooner than a mainnet node. The mainnet will grow slowly, and because we believe that's the secure way to grow it. But the mirror network can grow very fast. Every single bit of the ledger will end up on a mirror node. Every transaction that goes through the ledger will go through every mirror node. But the mirror nodes only receive information. They don't push information to mainnet, and mainnet does not pull information from mirror nodes. Mainnet nodes will pick mirror nodes at random and send them transactions, events. It's the mainnet that's picking the mirror nodes that they're gossiping to, and the mirror nodes will then gossip amongst themselves in order to ensure the speedy delivery of all those transaction events to the entire mirror network. So the mirror network or mirror net are computers that keep a copy of the whole ledger. They can, and it's the way it works is you don't have to pay anything to be a mirror node. You can host one, and the mirror nodes help each other sharing information, and they don't slow the main network. And moreover, they don't affect the security of the main network. It does require, the mirror node does require enough bandwidth and storage and processing to do what a main network would be doing, because it's doing everything a mainnet node would do, and then shares it with the rest. So they gossip amongst each other. They perform consensus, or they calculate consensus, just like any of the other mirror nodes on the network and the mainnet network, but they're not participating in the mainnet consensus per se. It's an information economy. There are no payments or money being transferred between mirror nodes. The mirror net is there and requires no crypto payments between nodes. If the mirror node wants to implement services that have a fee and a cost, then it can do so. That will be up to the mirror node itself. So that's how the cryptoeconomics work out. We're trying to avoid the tragedy of the commons, where things are overused. The fees exist to protect the network from attack. Staking prevents Sybil attacks. We have fees to avoid all of the above in terms of protection. We try to incentivize the nodes with payments. We allow clients to pay for data, and you can do micropayments, which you can also do on a mirror node, which will create an entire new economy of businesses selling services on mirror nodes, all free, or for themselves, or maybe to archive everything, or to archive things that they're interested in, or archive things that other clients have suggested might be interested and that they want notifications for. Yeah, the mirror network and the cryptoeconomics are there specifically, or more specifically, to recognize the fact that resources are being used on the network, and those resources have a cost, and that we can't do everything for free, otherwise chaos would ensue.